So we need to understand how to convert a binary value into its denary equivalent when 2's complement notation is used. So it's actually quite a straightforward process. It just requires some practice, and I'll also show you a quick cheat to check your work. So let's assume that we have this unknown number that we want to check the value of, assuming 2's complement. Now, first step is always the same, because the 1 at the front tells us whether a number is positive or negative. We know to invert and add 1. If it was a 0, we wouldn't do that, and that is the most common mistake students make, is that they always invert and add 1, which will give them an incorrect answer, assuming the number was positive. So the first step, invert all of our bits. Now take your time and do this carefully, just to make sure you don't make any mistakes. Okay, so now we've inverted it successfully. The next step is to add 1 on. Now I like to write it underneath here so that I can check my result as I work along. Now you should have already understood the 4 rules of addition in binary. 1 plus 1 in binary gives us 2, which is 1, 0. Now, like in math, we do carry over when the number is higher than the number of units that we have. So this 1 carries over again, and we have another 1 plus 1 to give us a second 2, which carries over. We have 1 plus 1, which again carries over, for another 1 plus 1, which again carries over, before finally having 0 plus 1, which gives us a 1, with no more carryover. So like in math, the rest of these numbers would be unchanged. Now this is our final value here, and again this is a place where students will make mistakes, so it's always best to check with your calculator. So let's just add up our placeholders. We've got 64 plus 32 plus 16 to give us 112. Now, if you to leave your answer like that, it would be incorrect. The only reason we did the invert and add 1 is because it was a negative number, and that is one of the simplest mistakes that people make. They do the inverting and adding 1 because it's 2's complement, but they forget to indicate it's a negative number. Now, another trap that people fall into is that when there's a 0 at the front, people automatically assume that this is negative, and they would go ahead and invert it, and then they would add 1, and they would work out to be the wrong answer. The best part of 2's complement is, because this most significant bit here tells us if it's positive or negative, this one's just a positive number. We don't have to invert and add 1, and it tells us that it's positive 20. It's the exact same result we would get just with normal binary. So it's really important that you practice as many of these as possible. Try one more. Okay, so pause the video and try and work out the result for this before continuing on. So we've got to invert it because the most significant bit is a 1. So invert all of the bits. 1s become 0s, 0s become 1s. Then we need to add 1 on. So 1 plus 1 gives us 2 with a carryover. 1 plus 1 gives us 2 with a carryover. 0 plus 1. And then there's no more carryover, so we write the rest of the number down. And a lot of students would actually stop and not write the final answer here. We've got to total it up, so we have 64 plus 32 plus 8 plus 4 to give us 108. And again, that famous mistake that everyone makes is to forget to put the negative for their answer. So have a practice at these. They become easier the more familiar you are with the procedure to convert them, and be careful when there's a 0 at the front in the most significant bit, because that would tell you it's a positive number and there's no need to even invert.